Alright, in this video we're going to look at right angle trigonometry. Now the first part of right angle trigonometry is to be able to determine the sides of the right triangle. To determine two of the sides of the right triangle, we need to use what's called the acute angle. And remember, an acute angle is an angle that is less than 90 degrees. The hypotenuse is the easiest side to find. It is always opposite the right angle, which is denoted by the little red box in this diagram, and is always the longest side of the triangle. To determine the other two sides is where the acute angle comes in. The first side is simply the opposite of the acute angle. Notice I have it here as a blue line with the blue arrow pointing to it. So we call it opposite because it's opposite the acute angle. The other side of the triangle is right next to the acute angle, and we call that the adjacent angle, and that's how you determine the sides. Remember, the hypotenuse is the easiest to find, and then to determine the opposite and the adjacent angle, we base it off of the acute angle that's given. After the sides of the triangle are determined, we now can move on to the three different trigonometric functions. And the names of those functions are sine, cosine, and tangent. When we're solving to find the missing sides or missing angles of a right triangle, we actually use the trigonometric ratios of these three functions. When we write the trigonometric ratios, we actually just use three letters of each of these functions. So for sine, we just have to drop the e, and it's sine of the angle equals to opposite over hypotenuse. Notice I said sine of the angle because sometimes the angle can be denoted as an x, a y, or even some of the Greek letters. As I stated earlier, for cosine we only need the three letters when writing out the trig ratio. So we would have cosine of the angle, which in our case is x, is equal to adjacent over hypotenuse. And then for tangent, using just the three letters, we have tangent of the angle is equal to opposite over adjacent. Notice the ratios of the parts that are written in words: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Remember, a ratio can be a type of fraction. To help you remember this, your teacher might have taught you using an acronym using the first letters of the sine function and the ratios. So for sine of x is equal to opposite over hypotenuse, using the first letters, we have SOH, or so. For cosine of x is equal to adjacent over hypotenuse, using the first letters, we have CAH, or ka. And then for tangent, using the first letters to create the acronym, we have tangent of x is equal to opposite over adjacent, TOA, or TOA. And so sometimes, to help you to remember it, we say Sohcahtoa. And this acronym can easily help you to remember and to write out the sine ratios when doing these type of problems. Now for all of this example, we've used x as our angle, and notice that our x is in the bottom right corner. But an acute angle can also be in the top corner. Remember that the sum of the interior angles of a triangle add up to 180. And because the 90-degree angle is in the bottom corner, denoted by the red box in our diagram, that means both angles can be acute angles. But now that we have our acute angle to be the top, this will change our sides. The only side that stays the same is the hypotenuse. Now remember, an acute angle is an angle that is less than 90 degrees. Our hypotenuse is always opposite the right angle and is always the longest side of the triangle. Remember, we're determining the other sides based over the location of the acute angle. So directly opposite this angle is the side that we call opposite. And right next to this angle is the angle we call adjacent, because adjacent means next to. So notice that our sides, opposite and adjacent, change because of the difference of the acute angle. Similarly, we can also determine our sine, cosine, and tangent, and therefore also our trigonometric ratios. But for this scenario, with the different acute angle, instead of sine x, we will have sine y equals to opposite over hypotenuse, cosine of y equals to adjacent over hypotenuse, and tangent of y equals to opposite over adjacent. We can still use the acronym of Sohcahtoa, but because of our acute angle has changed, our sides have changed also. Sometimes having them right next to each other can help us to spot the difference. Remember that the main difference is that the sides of the legs of the triangle are determined by the stated acute angle. If you want to have some worksheets that can help you understand this better, go ahead and click the two links that can take you to either the test website or Teachers Pay Teachers website, where you can download a whole curriculum guide with the answer keys. These worksheets are intentionally designed to make sure that you truly understand the basic concepts of doing trigonometric ratios. If you would like to see more math videos, make sure you like, share, and subscribe.